Hello, I think that this time I don't need to make any introductions. So let's go directly to the main subject. Space weather activity in last couple days. As you can see on the ACE plasma parameters chart, there were three separate impacts of fast solar particles. First event took place on December 21, around 19 UTC. Second one was recorded almost exactly one day later. Last impact took place around noon on December 23. First two impacts were connected with increased density of solar wind, what is a clear sign that they were caused by CMEs. However, the third event was different. Density didn't grow too much during the impact, and later it started even to drop. Besides, last wave affected the temperature much stronger than previous ones, what is typical for coronal hole streams. But I'm not sure if... Anyway, first event is a perfect example of a coronal mass ejection and its effect on geomagnetic field. Impact of the first wave was recorded by most of magnetometers over the entire planet. Just as it's supposed to be, as geomagnetic storms caused by CMEs supposed to affect the field on global scale. Especially when the magnetic orientation of IMF is pointing south. BZ shows the negative values. But to take a closer look, I will have to use ISWA. This solar wind monitor is much more accurate. As you can see on the bottom screen, BZ was negative even before the impact, and its value oscillated around minus 7 nanoteslas. CME wave is hard to miss, as it is visible on all graphs, but most important is the BZ component, which went below minus 10 nanoteslas at the time of CME arrival. Such value is more than enough to trigger a geomagnetic storm. And indeed, the KP index grew to 5, but with couple hours of delay. According to official data, storm started after the midnight. At this time, BZ component reached minus 16 nanoteslas, what should trigger a serious outburst of auroras. But in Kiruna, local K index was elevated to 6 during the initial impact. Just as after the midnight, when another serious disturbances were caused by the southward IMF orientation. Geomagnetic field took a serious hit which reached almost 700 nanoteslas. But now let's look at the auroras on Kiruna all-sky camera. First, let's check the initial impact which took place around 19 UTC. If you wanted to see a spectacular show on the sky, you should be disappointed. If you look closely, you will see that indeed there was a visible aurora, but it was rather pathetic. So, let's check the images from the time when KP index reached 5. And again, a huge disappointment. The sky became slightly green, but it was the only visible response for geomagnetic disturbances, which for sure were not weak. Around 4 UTC, on the next day, BZ started to point north, what caused the geomagnetic instabilities to fade. It is hard to notice the impact on SWMF plus RCM monitors, but I will show it to you anyway. there was a lot of density spikes during the entire event. But I can't leave the first CME impact without mentioning the backside gust of neutral particles, which can be seen on radiation belt monitors at the lowest energies. But when we'll look at electrons at minus 50 kilon electrovolts, we will learn about another important process which is caused by those gusts. It seems that the force which is responsible for those disturbances is strong enough to blow away particles with low energy levels out from our magnetic field. High energy electrons are much more sensitive for the magnetic influences and they can resist the pressure of neutral particles. However, even energetic particles are clearly affected by those gusts, which cause a clear compression of Van Allen belts. I wonder if neutral particles are responsible as well for this sudden drop of cosmic ray density, but this needs a further research. Anyway, I can't call this event as an example of typical space weather activity for another reason. It seems that despite the elevated Kp index, this CME impact didn't affect the temperature of ionosphere at all. Neutral gas and plasma didn't react in any visible way to the increased space weather activity. Actually, we won't see any visible effect of the first impact on any of CTIPE monitors. Height of F2 layer was dangerously low through the entire day, and CME wave didn't change it in any way. Neither did atomic oxygen and other ions which create the ionosphere. I could still tell you about couple things regarding the event from December 21st, but it would need a longer explanation, so for now I will move to the second impact, which took place on the next day afternoon, around 15:30 UTC. Magnetic orientation frozen within the CME was turned north during the passage of wave. PZ reached 22 nanoteslas. However, during the initial interplanetary shock, BY component, showing the east-west orientation of field lines, was stronger than BZ. BX was close to zero. This is the response of our geomagnetic field. It didn't hurt. However, in Dixon Station, which is placed in Arctic, shock reached almost 1000 nanoteslas. Nice. Just like in the previous case, ionosphere wasn't affected by the impact. HMF2 shows a strong compression of ionosphere, just as it did before. But the second impact is for sure worth to notice for one reason. It shows perfectly how bad is the shape of our magnetosphere. I could spend 1 hour to tell you how wrong was the response of magnetosphere to the second CME wave. Those couple frames made for sure some people to scratch their heads. First of all, notice how big is the density of particles on the far side of magnetotail. This is a clear sign of increased backside pressure. Here you can see as the direction of field lines is changing, allowing the magnetosphere to connect with the IMF. Notice that only the south pole is capable to connect. It's caused by the orientation of geomagnetic field. Field lines which are connected to the south polar cap are directed outward. Northern open field lines which have inward orientation disappeared completely or were turned into closed, red ones. Look what is happening with the plasma sphere due to lack of northern open field lines. Similar plasma loops I was showing you in one of my last movies. However, it is visible that big part of energetic particles is leaving the magnetosphere. This doesn't look good. Look at the breach which appeared on the magnetopost position monitor. And this is the best part. Entire magnetosphere is visibly tilted to the side. Notice as well that the backside pressure managed to push the bow shock away from the magnetosphere. Another event from December 22, which is worth to mention, is the crossing of a sector boundary. Earth moved from the positive part of IMF to the negative one. Okay, time to move to the third event, which raised the velocity of solar wind higher than previous two impacts. Although it seems that the last wave was much less dense than the others. After the initial impact, density started to drop visibly, what tells me that it might be a coronal hole stream. What makes this event interesting is the fact that it caused a sudden jump of high energy and low energy protons. However, electrons seem to be affected much less. Notice this strange spike on ACE readings. I will come back to it later. Just as before, impact affected the geomagnetic field on global scale, but the disturbance was tiny. At least in Europe. In Canada the disturbance was stronger. But because impact took place around 12 UTC, I can't tell if it caused any auroras. Anyway, like before, the ionosphere seemed to be completely unaffected by this event. Compression of the ionosphere didn't change a bit, and the height of F2 layer remained at irrationally low level all the time. The response of magnetosphere seems to be very similar to the previous impact. It was wrong. Compression of magnetic field was even bigger than during last event. But notice that this time open field lines disappeared from the south polar cap, and it was the North Pole which was connected to the IMF. Luckily, couple hours later, shape of magnetosphere returned to the state which can be called typical. Okay, that's it for the triple impact. Now let's start with some serious issues, which started couple hours later. Around 21st UTC, a sudden geomagnetic pulse was recorded in Europe. It was much stronger than the disturbances caused by solar activity, and K-index reached 7 points in Kiruna. Look at the auroras which were caused by this event. According to official explanation, red color is caused by atomic oxygen particles which give away the additional energy by releasing photons at high altitudes. But this process should take place only during very strong solar activities. It could be caused by the negative BZ, but there is a small problem. One day later, on December 24th, geomagnetic disturbances became even stronger. Here you can see two strong pulses, where one caused a drop of magnetic field magnitude to less than 10,000 nanoteslas on X orientation. K-index reached 7 again. During this evening there were two outbursts of auroras over Kiruna, and both were spectacular. However, this time the BZ component was oscillating around -5 nanoteslas, what is rather too low to cause such strong disturbances. Of course, SWPC didn't notice those pulses, and KP index was at 3 during the strongest auroras. And here comes the funny part. One day after, on December 25th, BZ fell to -10 nanoteslas, what should cause much stronger disturbances. But in Kiruna, the geomagnetic pulsation was weaker than day earlier, and local K-index reached only 5 points. It can be connected with the increase of solar wind density. Solar particles are protecting our planet from the rogue magnetic influence. During the day when I'm recording this movie, another strong and unexplained pulse was recorded in Kiruna. K-index hit 7 once more. And it seems that it was taking place at the time when BZ component was turning north. And now I would like to move to another subject. This video, uploaded on December 23rd by Dark Sky Watcher 74, caused a lot of discussion in last couple days. First, let me show you what it is all about. As you've seen on this short movie, DSW74 recorded on his webcam some odd activity around the Sun. Those anomalies look for me and for many others like some kind of energy bursts or lightnings, which seem to originate from our star. So I've checked the space weather conditions at the time when this anomaly was taking place. Although DSW74 didn't give any information about the exact time of recording, it took place soon after sunrise in Kingman, Arizona. By coincidence, around this time Earth was under the influence of the third impact, which contained huge amount of protons. Anyway, this was not the first movie with this strange anomaly which he recorded on this webcam. First one was uploaded on his channel on the last day of March. Again, there is no exact time of recording. But if the movie was recorded around this time, then there can be a chance to find a pattern. And the chance is even bigger when we will compare his third recording, which was uploaded on 6th April, with the Goes proton flux graph, and we will see another wave of energetic particles, which was recorded by the satellites one day earlier. For the end, I will use one of my new toys to show you how magnetic fields affect the atmosphere. Look at the image in upper left corner. Around November 24, we can see something what can be seen quite often on current ring monitors. A field line connecting to the inner parts of magnetosphere. Couple days later, on first day of December, the connection ends. And by coincidence, on the same day we can see on the current ring monitors as the equatorial connection is going through a visible change. And this is the last monitor for today. This animation shows the evolution of polar vortex shape over the northern hemisphere. Class dismissed. Be safe. Peace.